So that's one problem with me. I'll forget recording it, so keep reminding me once so that I
Okay,
don't
yeah,
forget.
sure.
So we have sketcher module, we have part design module, we have wireframe and surface design, then sheet metal design, assembly and drafting. So in Sketcher, basically it is the foundation of any 3D modeling, very basic foundation. If it's not strong
Mhm.
enough, it's going to completely destroy your model. So one of the problems that will occur is, see, do you know what is constraints?
Constraints is, just applying constraints, right? Like beyond which the design shouldn't change, something like that.
Um, it's like, yeah, that's correct. So constraint is like fixing it properly and constraining with respect to the other elements of it. So like if you're building something, so just imagine your links. Okay, link in the sense, you know, link, right? If you have camshaft and the piston, you'll have a link connecting
Mm-hmm.
that to the flywheel. So what
Mm-hmm.
happens is, if the link is not proper, it's going to just fall apart. Okay, so link
Yeah.
is very important. So the one of the main problems that you're going to face is, so you're transferring the file to somebody. Like if you're sending it to the manufacturing person, or if the moment you save it and if you just open rebuild, if the constraint is
Mm-hmm.
not proper,
Mm-hmm.
what is going to happen is the sketch is completely changed. Okay, the sketch will completely change the moment you just share the file to something else and somebody else opens it. So
Mm-hmm.
that's the one of the greatest problems that you'll face. So whatever you're doing,
Okay.
whatever sketch you're doing, be it a single line also, it should be properly
Mm-hmm.
constrained so that it doesn't move even a bit. Okay, the like once your model is done, the entire thing should be in total green. Okay, green is for constraint, so the whole thing should be constrained perfectly, so that
Okay.
and once it's done, you should just check it also. You should take your cursor, just hold it and just try to move it here and there, and if it's not moving and it's positioned properly, then it's constrained. So once it's constrained, then
Okay.
you can exit it. Before
Mm-hmm.
if it's not constrained, then you should not exit it. Then
Okay.
you have part design workbench. In part design workbench, what is happening is, and yeah, one more thing in Sketcher you should remember is selecting the planes. So selecting
Mm-hmm.
planes is very important. It What happens is, like, some people now, what they just take random planes, and they start sketching it. So you
Mm-hmm.
should observe the image. You should observe the model first. Whatever drafting you have at your hand before 3D modeling, first you should observe it, take few minutes, and just study it and see which is the easiest way in which you can do that model. So that you don't waste your time. So I'll give you one example. Yeah, I'll just do it. This, this experimental folder. A simple example. Let's see.
Mm-hmm.
See, this itself we can do it in multiple ways. Okay, so now you can see this. See, if you want, you can start from the top plane. Okay, XY plane, and you can just draw this. Okay, then you can
Mm-hmm.
extrude a top face. Okay, top face like this. Then you can draw this part and you can then extrude it again. Or you can take your side plane, right side plane or left side plane, and you can draw this element like this, and you can
Mm-hmm.
extrude it both ways. So that's more convenient. See, if you do it top face, if you select the top plane, first you have to do this part. You have to draw this, you have to do this part, then you have to draw this rectangle, then you have to extrude it 28, then you have to draw this rectangle, you have to extrude it 16. So it's three steps. So three
Mm-hmm.
step unnecessary three steps you're taking here. So instead of that, what you can do is you can just take the side view, side plane, and you can just draw this, and you can just extrude it to a distance of how much? To a distance of 43 plus 43, 86. 86 we can extrude it.
Okay.
So like that, you can save your time and energy. Because
Mm-hmm.
whatever design you're doing, it should be very simple and very
Mm-hmm.
structured.
Okay.
Okay. So that's one example. So where is
Mm-hmm.
this? So that's SketchUp. Then we have part design. So part design basically it's creating a solid model from a 2D sketch.
Mm-hmm.
So in part design we have a lot of options in the sense, lot of in Sketch also we have a lot of. Do you know AutoCAD? How to use AutoCAD?
Yes, I have used it.
So in Sketcher, all the AutoCAD tools, whatever you have used, everything is there. Like the
Yeah.
profile command, the rectangles, the circles, the spline, the ellipse, the line, the construction line, the point. Then you have fillets, chamfer, then trim option. Then you have mirror
Mm-hmm.
option. You have
Mirror
yeah.
projection.
Yeah, projections. Then you have this thing. Lot of other options also. We have symmetry option. We have
Yeah.
so many other options you have. See, you have this drop down
Mm-hmm.
icon, right? In drop down icon, you
Mm-hmm.
have multiple other options. So wherever drop down icon
Yeah,
is
yeah.
there, all those places you have multiple options. Then you have constraint
Yeah.
tools. So you have two
Mm-hmm.
different types of constraints. Can you just name it?
Mm.
Two different types.
Uh,
Yeah.
yeah, I think one is like hard constraint and one is I think I mean if you select something it will automatically constrain all the sides. Something like that.
Mhm. Not that. See, we have two different constraints. One is dimensional constraints and one is geometric constraints. Okay, these are two different types of constraints. One is dimensionally constraining it. Okay, dimensionally constraining means if you have a center origin point, it will be stationary. So it's a fixed point,
Uh-huh.
origin point.
Yeah.
So what you
Mm-hmm.
can do is you can dimensionally constrain it with respect to the origin point. You can give the length, the breadth, the height, and all those things, and you can just constrain it with respect to the origin point, and it will be totally constrained. Then comes the
Okay.
geometric constraints. Geometric constraints is you have parallelism, perpendicularity, circularity, concentricity, then all those things, parallelism, and everything will come, and that is completely different. So that you can
Mm.
do, and you can constrain it. Okay, using geometry constraints. So you can
Okay.
use geometry constraint to constrain it, or you can use dimensional constraint to constrain it, or you can use
Mm-hmm.
combination of both to constrain it. Okay,
Mm-hmm.
and you can even use symmetry command for ease of doing it, so you don't have to complicate
Okay.
your design. So if it's a
Mm-hmm.
complex design with similar sides and angles, then what you can do is you can easily use symmetry command. So whatever changes you make in one side, that is reflected on the other side, and you can save both time and your energy.
Mm-hmm.
Okay, is that fine?
Okay. Okay. So, like, what constraint would you recommend? Using both, or
Yeah,
you know,
100%
what do
using
you
both.
normally do?
I use
Okay.
both. I use both.
Okay.
Most of the things can be constrained using dimension itself. You don't
Mm-hmm.
require this, but the thing is, like, there will be certain aspects where you have to use the constraints. Okay, like if you're using, see, similar, like if it's in an angle. Okay, if it's an angle, then I have to give 30-degree angle in one place, and I have to give 30-degree angle in another place. Okay, it's
Mm-hmm.
again like two to three places I have to give it. So better than that, if they are like facing each other, so what I'll do is I'll give 30-degree angle for one, the other part I'll just mirror it. Like I'll just give parallel constraint. So what is happening is, I don't have to give 30-degree angle here. I just have to give one single constraint, and the side will be done. And if it's like see, if a line is horizontal line, or a line is vertical line, so I don't have to
Mm-hmm.
give an angle of 0 degrees to make it horizontal, or I don't have to give a, dimensional angle of 90 degrees to make it vertical. Okay, that is dimensional
Mm-hmm.
constraint. I don't have to give that. I can directly use
Mm-hmm.
constraints like horizontal constraint and vertical constraint to do that. So it'll simplify it. In certain places that we have to use dimensions, certain places we have to use constraints. So it's a combination of both.
Mm-hmm.
Both will support each other. Okay.
Okay. Okay.
Yes. So you can constrain it completely using dimensional constraint, no problem. But there'll be a lot of lines
Mm-hmm.
and things in your sketch you won't be able to understand. You'll go crazy. So better than that is you can use your
Mm-hmm.
this thing, geometric constraints. So like I said you right, if you have a circle and if you have multiple objects and everything, so directly if you give symmetry, so you don't have to constrain the
Mm-hmm.
rest. Symmetry is a geometry
Okay.
constraints. So if you give symmetry, you don't have to constrain anything else. Only one single part if you constrain, that is done. Okay, like that.
Okay.
So
Okay.
what you have to see is you have to just take some time and you should see how to make it more easy, how to make it more simple, and how to do it
Mm.
faster. Okay, not to complicate
Okay.
it. Okay, there is like
Mm-hmm.
to do anything there's like thousands
Okay.
and thousands of ways, but the main thing
Okay.
is you have to know how to do it simple and easy way, so that next
Mm-hmm.
like always think as a designer, it's like your when your design
Mm-hmm.
is complete, it's not complete, it's a beginning of your
Mm-hmm.
design. Because like if you're doing
Okay.
a concept design or something, what is happening is, see, you'll put your days and nights into work and you'll complete the design. Okay, once it goes
Mm-hmm.
for approval, they'll come up with a lot of small modifications. But in 3D modeling,
Mm-hmm.
what happens with the small modification is the moment you just make any changes, the whole row will be like you'll have pop-ups, this error, that error, this error, that error, this error, that error. Okay, you'll be like
Mm-hmm.
you'll have hundreds of different errors. Okay, so it'll be like you'll go crazy. What the hell I did so difficultly, and they asked to change a small thing, and the whole structure, like the whole specification tree is showing red because I am not able to change it. Okay, that is when it'll hurt you a lot. Okay, I
Mm-hmm.
used to do a lot of freelancing projects, so I'll show you some of the projects that I have done.
Mm-hmm.
So in freelancing, what has happened? That's when I learned how to make it make models simple. Because at that time, what used to happen is I used to do all these models, and all of a sudden, and
Mm-hmm.
this thing, all of a sudden, what happens is they'll come with
Mm-hmm.
small modifications, and the whole thing used to go haywire, and I used to find it really difficult for doing all these things.
Mm-hmm.
Shit. Cheap reach. So this one model had to do for them. So like this, I have done plenty of models.
Okay.
Models.
So typically, how much time does it take to build a model like that?
It takes a lot of time. I'll show
Okay.
you an animation. One more thing which I have done. Photos are this anime, animation. Filmmaker. And I know Keyshot software also.
What is it?
Keyshot. Keyshot is a rendering software.
Keyshot?
Yeah, Keyshot.
What is that called? I mean, what it used for?
It's used for rendering. So once you
Okay.
do this, once you create a model, it's very
Mm-hmm.
mandatory to do the presentation, right? For investment
Mm-hmm.
and everything. So for doing presentation, you need something in your hand which
Mm-hmm.
is show worthy. So like this. So that's one model
Okay.
which I had done. This I had done for $300 or something.
Oh, okay. So you use a rendering software to display your design.
Yeah,
Okay.
because it's
So
for them to
there's,
understand, right? Whatever
yeah,
they
yeah,
have
yeah.
asked, what they have asked that
Mm-hmm.
we have incorporated. So I can't
Okay.
because this is the thing, right? They're like US clients only. So I can't just
Mm-hmm.
go to them and show ki see this. Okay. So it's better to show
Okay.
them the video and see what you have
Mm-hmm.
asked. I have put. Now
Yeah.
just put that money in my account. With that I can see. Then the work will be done.
Okay. Yeah. It is neat.
Yeah. So actually, there's one more video. This is actually the first old video, and the
Okay.
actual video, this thing all will be moving.
Mm-hmm.
All the things will be functioning. So it's old one. Where it is from
So
one
how
year.
many years have you been doing?
I think I'm just 26, so I think 2 years, 2 years, not 2 years. I think one this 2020 was totally in this company. I was like, I didn't have any time for any freelancing. So before that,
Okay.
I used to work for 6 7 months. I had done this 6 7 months. I
Oh,
have
6 7
yeah, that's it.
worked as a freelancer.
Yeah, I was just doing for
Okay.
time pass.
So, oh, how long have you been working in your electronics, whatever, electronic wing,
Electrowing, electrowing.
electrowing technologies?
Yeah. So I've been working there for 1 year now. 1 year is over.
Okay.
Electrowing.
So are you in India now? Is that in India or here?
Yeah, it's here in India only.
Okay.
Yes.
Bangalore. Okay.
Yeah, this is a company.
Okay. Interesting.
So we do all, even electrical components also. Power, like power supplies for all those things we do. Ships
Mm-hmm.
and everything we do. So along with that, we have mechanical department where we do all the thermal management. So we had recently supplied a radiator for a satellite.
Oh,
So,
okay.
and you know this thing, Gaganyaan project, Gaganyaan,
Which one?
Indian astronaut.
Uh-huh. Yeah, yeah.
So yeah, so for that we are developing heat exchangers for the
Oh,
thing THCS, that is like temperature humidity control system. For
oh,
them. Yeah, so we are developing heat exchangers. Then we are liquid to liquid heat exchanger, air to liquid heat
okay.
exchanger. All those things
Mm-hmm.
we are developing, and we have
Okay.
our own facility also in Bellesti, where we have
Okay.
this vacuum raising, thick welding, and everything.
Oh,
So
okay.
it's
That
very,
is really interesting. So, my thesis was on heat exchangers.
very good. Yeah, fantastic.
Yeah.
So you'll know calculations, right? Heat exchanger calculations.
Not necessarily. So I did like experimentation. So mine involved like, iterations of, experiments. So, I didn't do the analytical part of it.
Okay.
So
So
not too much
this
checklist, only the iterations.
discussing project, I had stopped the recording. So why we use PCM heat exchangers? Even the aircraft is in the flying condition, they have scoops which take the air from ambient air and they cool the heat exchangers. So mostly plate fin
Mm.
heat exchangers and everything, they cool it using the ambient air which is taken from the taken from outside ambient air. So what
Mm-hmm.
happens when the flight is in the ground level? What happens is
Mm-hmm.
there is not enough air which is pumping into the heat exchanger
Mm-hmm.
fins to cool it. So
Mm-hmm.
at that time, what happens is even a minimal electronic movement also will increase the temperature. Okay, the
Mm-hmm.
purpose of heat exchangers is to control the temperature. It shouldn't, like, all the electronics should be in 45-degree range. Any radar or anything should be in that temperature range. But the moment it goes up, the whole things will get short, electronics
Mm-hmm.
will get short, and so it's very expensive. So for that reason, in the ground level, when the flight is in ground level, it has an external fan for cooling. But when the moment it's taking off, 5 minutes, in that 5 6 minutes time range, that fan won't be working. So at that, for 5 6 minutes, they're using a PCM heat exchangers. What happens is they have that organic compound, right? Which material are you using for PCM?
So I used ice and some disulfate or something.
Okay, okay. We are using A43 organic compound. So that what happens, it's a wax kind of thing. So at 43, A43 is a code name. So at 40 degrees it'll start melting correctly. So as I told you, 45 degrees you should maintain. So at that taking of 5 minutes time, whatever electronics, mainly all the electronics will be switched off in aircraft. All the radar, everything will be switched off while taking off, because that adequate this thing current and adequate cooling is not there. So most of the things, or
Mm-hmm.
90% of the things will be off. So other 10% cooling PCM will be doing. So what happens
Okay.
is this thing, just like ice itself, this PCM organic compound is like wax form.
Mm-hmm.
So it absorbs the heat
Yeah,
and
yeah.
it'll melt. So it'll become
Yeah,
from
yeah.
solid state to liquid state. So the
Liquid
moment
state.
it's the moment the aircraft is in air, so that
Mm-hmm.
ambient cooling, outside external air cooling will start, and this PCM is cooled back again, and the other heat exchangers take over. So it's like that.
Mm-hmm.
So we have
Yeah.
done one PCM heat exchanger also. That's first time in India actually. We are developing it.
Oh, okay.
So yeah. So
Yeah.
what was I saying? Sketch based or
Your
see
work.
in yeah.
Mm-hmm. Your work seems really interesting.
Yeah, it is. It's like all, what do you say? Like, because most of the things are not there in India, so you're bringing everything here. So, be it liquid
Yeah.
cooling unit or many things, ACMs. So,
Mm-hmm.
these things are like there in US and everywhere, right? But in India, we don't have.
Mm-hmm.
And
Mm-hmm.
mostly in ADA. ADA, they have
Okay.
most of the things they have developed it, but there are some things which they have not developed it. So, even that we are developing. It's a good thing. So, we are
Mm-hmm.
indigenizing most of the
Okay.
things.
Okay.
Yeah. So coming to this toolbars and part design. So
Mm-hmm.
sketch-based features. So in sketch-based features, like once the sketch is done, then you have to
Yeah.
create a 3D model out of it. So for creating 3D
Mm-hmm.
model, we have different like tools. Like we have pad command, we have extrude, we have revolve. So we have multiple
Mm-hmm.
options like this. So which will enhance
Mm-hmm.
our design. Then we have dresser
Mm-hmm.
features like fillets and everything, which will
Mm-hmm.
again simplify everything. So one more thing, okay, I'm doing, I'll explain. Then we have the assembly design. Assembly design is again like combining to check if the functionality is okay.
Mm-hmm.
For example, like you have a pen, you have a pen body, you have its cap, you have its refill, you have its this thing, nib and everything. So what is happening
Mm-hmm.
is like you have to check the functionality. So if you're working in a company, you'll have three designers. So one person will do the body, one person will do the refill, one person will do the cap, and one person will do the nib. So what is happening is at last you have one person will be daydreaming or something. He will by mistake just what do you say? He'll just increase the tolerance, or instead of 0.01 he gives you zero point 0.1. Okay, he'll give that,
Mm-hmm.
and he'll give you the model. So you have to check if everything is functionally okay, all the tolerance is good or not. So when you do the assembly, so that's when you see a
Mm-hmm.
gap. Okay, you see a gap, so you'll the moment you see it, you'll understand that there's something wrong with this. So you can do take the preventive actions, and there is one more thing, you can do the analysis also. Like you said,
Mm-hmm.
like the CFD analysis and structural analysis, you can do some analysis and check the structural integrity of the product. Like
Mm-hmm.
if see, if you take example, if you have two companies manufacturing the same similar product, you have one company like the some name you can give, and one more company there, and these two are manufacturing marker pens. Okay, and one company is too conventional, and they just do random testing and everything. So what happens is they'll build a draw it pen in paper, and they'll just give it for manufacturing. And one more company is your company, where you design it, then you just check the functionality. You see how much material is required, how much material is not required, what is adequate, what is not adequate. So according to that, functionality wise, you'll decrease the thickness of the material, or else you'll increase the thickness. So you'll know exactly how much material has to be used. So the other company, they just go with the intuition, they just manufacture it. So what is happening is his pen will have point 1 mm thickness, no, 0.8 mm or 0.5 mm thickness, and your pen will have only 0.3 mm thickness, which is much adequate, and you'll have give some rips or something to make it strong enough. So what is happening is zero point 0.5 increase is actually a huge, like he's selling the pen at the same rate, you're also selling the pen at the same rate, but his
Mhm.
loss is more because he's using up more material than what you're using. So the profit
Yeah.
margin that you're making is more compared to him. So it's a small
Mhm.
things which will affect the entire thing. So that
Okay.
person will be wondering ki why you people are doing it, you're getting so much profit and he's not able to make any profit out of it. So these are the reasons. So anything that is done, you have to check its thing and you have to do it. The part product
Mm-hmm.
assembly, I do not join.
Okay.
The product assembly structure is hierarchical and allows you to model complex product relationships. Constraints can be applied between the parts in yeah, you can apply the constraints between the parts. So you can constrain the cap to the body and everything, and you can constrain all those things. Refills should be concentric to the body and everything. You can do it. You can constrain. So you have different constraint tools like coincidence, contact, offset, angular, then product structure, insert new product, insert new part, and everything. Different options. Steps for creating an assembly: create new CAD product using file new product, using product structure tools. Okay, these are all steps. So I think so much is enough for today.
Okay. Yeah.
Some more things. Yeah, wireframe surface design and anything else. Yeah, wireframe surface design. You have how to design the wireframe and surface. So
Mm-hmm.
you have some tools like this. This is your drafting. How you're drafting here. Yes. Okay.
Okay. So, I wanted to ask, like, if you will be giving this PPT and I have to do that drafting in the last diagram or something like that?
There's nothing here. Yeah. Mhm.
No, no, no. There were examples for drafting, right? Should I be doing, or is it just to show?
It's this one, nah? The other one, yeah, that we have to do it. That we'll be doing it in the class.
Okay. So, do you have, do you want me to install the new Catia? Will you be providing with the Catia software?
I have given it to the support team. I think they will give it to you. They'll share it to you.
Okay.
Yeah.
Okay. They haven't given me any information. That's why I'm asking you.
We will give it. Let me check.
Oh, you're coughing in Corona times.
Yeah. The climate is too cold here. And it's what 6, right? 6 a.m.
Oh, yeah. So you're managing this in in the morning and then you are working again.
Yeah. And the time, everything is crazy. I go at
Okay.
9:30. I come back at 10 p.m. 9:30
Oh my
p.m.
God.
like that. Yeah, it's crazy.
That, yeah, that's like more than 12 hours. Why would you work so much?
Not well, 14, 15, 16 hours we have worked. Last Thursday I worked whole night. Next day I went to office, I worked whole day.
Oh my, okay.
It's
In
crazy.
Yeah. So when I was working in a it used to happen too.
Hmm. It's like mostly it's more not about the money, it's more about commitments. Like we feel sad for them, we feel like doing something.
Hmm. Oh, you have did ergonomics too?
Yeah,
Okay.
that's just for
Oh.
representation, like for the
Mm-hmm.
client, no?
Yeah, yeah. Okay. I just want to I just want to know like if this just gives the basic introduction of Katia, or will we be doing any complex designs?
We
I
will
want
do
to
it.
improve.
Yeah, we'll do it.
Okay.
Since you already know, see the thing, what happens is, like in the batch, if somebody is new, right? If a person doesn't know anything and he comes, so what we have to do is we have to go in detail. We have to explain
Mm-hmm.
each and everything to them, right? We have to go
Yeah.
slow. We
Yeah.
have to
Yeah.
go
Mm-hmm.
easy on them. So, but since you know the
Yeah.
software, there's no point in wasting time with the basics. That's
Mm-hmm.
why usually I don't take so much also. Like introduction class, I'll just say, Katia, yeah, this is that's then I'll just talk.
Okay.
So I went into
Mm-hmm.
detail because you already know it. So there's no point
Yeah.
in wasting time there, right?
Yeah.
What is this? I think it's with the support team. I think they will only you can just text them or
Mm-hmm.
something. They'll give it to you.
Okay.
Or else
Okay. Okay.
I'll have to upload it. I'll do one thing. I'll give you my number. If you don't get it, then
Okay.
just let me just remind me. I'll just
Okay.
try to.
Okay.
And the storage is full. It was
Okay.
supposed to be 100 GB. Now it's gone back to 15. Crazy.
Oh, but isn't it usually 15?
Yeah, it is usually 15. What happened is I had taken an Asus phone when I was in college. So if you have Asus, what is happening is like they'll give you 100 GB free storage. So I had that
Oh.
100 GB. Now what happened is I changed my phone, and the moment I changed my
Ah.
email address, and they just cut short that total GB.
Oh my. Okay.
So yeah, so you can take my number. It's
Yep.
996633915110. Just remind me. If in case they don't give it to you, we can just yeah, it's in
Nine.
the
Okay.
yeah nine
One.
double six double three nine one five zero.
Mhm. Okay. Yep. Thank
They
you.
have it. They
So,
have it with them. Yeah, tell me.
is it Catia V5 or V6?
V5, V6 is the same.
V5.
Yeah,
Okay. Yeah.
is that
I.
random? Same it here somewhere.
So, how much difference is Catia and SolidWorks?
How much difference is Cations? A lot of difference. Lots and lots.
Yeah, I try. I mean, I worked with SolidWorks like I think 4 years ago,
Mm-hmm.
and yeah, I forgotten all about it. So
SolidWorks is a lot more important compared to CATIA right now because like
okay,
to land a small scale job, you have to start with SolidWorks.
yeah, I was kind of wondering why they took Catia instead of SolidWorks, but the only option they had was Catia, so I had to take Catia.
Yeah.
Mm,
So if you
Okay,
are interested for SolidWorks, you can let me know. We'll plan something.
okay,
Yeah.
okay, that'll be great.
Okay then.
Mm.
Chalo then we'll wind up for today.
Okay, yep.
Sure. Okay then. Bye. See you.
Thank you so much.
Yeah. Sure thing. Bye.
Yeah, Vishnu, right?
Yeah,
Yes.
Vishnu. Yeah.
Okay. Nice
Okay
to
then.
meet you.
Yeah. See you. Bye.
Mm-hmm. Bye bye.